Welcome to Section 9.3, Two Counting Principles. At the end of this section, you should be able to answer these questions. What are independent events? What are mutually exclusive events? When are we concerned with independent events? When are we concerned with mutually exclusive events? What mathematical operation do we use in an AND situation? What mathematical operation do we use in an OR situation? What does the notation n of B vertical line A represent? How do we compute the number of outcomes in an OR situation that contains non-mutually exclusive events? In calculating probability, our definition is that the probability that a certain event occurs is equal to the number of ways that that event can occur divided by the total number of possible outcomes in our sample space. So, to come up with correct probabilities, it's very important that we calculate the number of ways things can occur accurately. So we're going to look at a couple of different types of situations where things can occur. Here's our first situation. Suppose a summer camp offers 4 outdoor activities and 3 indoor activities. Those outdoor activities being swimming, canoeing, volleyball, and archery. The indoor activities being pottery, computers, and music. So let's call swimming S, canoeing CA, volleyball V, archery A, pottery P, computers CO, and music M. Now on Monday, each camper is assigned an outdoor activity in the morning and an indoor activity in the afternoon. In how many ways can the 2 activities be chosen? Well, let's write out all the possible combinations. I could have swimming and pottery, swimming and computers, swimming and music, or canoeing and pottery, canoeing and computers, canoeing and music, or volleyball pottery, volleyball computers, or volleyball music. Finally, archery and pottery, archery computers, and archery music. So we can see that we have a total of 12 possible ways the activity can be chosen. Now, if we had to outline every time we had a situation like this, that could take a lot of time. So what we're looking for is a method to determine this total of 12 without having to detail every instance. What we can see is that for every one of my first activities, I have 3 possibilities. So if I have 4 possibilities in the morning and 3 possibilities for each of those 4 morning activities for an afternoon activity, I end up with a total of 12. So I multiply 4 times 3 and I get 12. Let's look at another situation. On Tuesday, the outdoor activities are canceled because of a thunderstorm. So each camper is assigned an indoor activity in the morning and a different indoor activity in the afternoon. In how many ways can the 2 activities be chosen? For our first activity in the morning, I have 3 choices: my pottery, computers, and music. In the afternoon, I've already used one of my choices, so I only have 2 choices for the afternoon, because one of my choices has been eliminated. So now, for each of these, I would have 2 possibilities, which would give me a total of 6 possible ways the 2 activities could be chosen. Note that what happens in the afternoon isn't affected by your choice in the morning. Doesn't matter whether I choose swimming, canoeing, volleyball, or archery, I still have the same 3 choices in the afternoon. In this case, what we say is that the events are independent. My morning choice doesn't affect my afternoon choice. Let's look at another example. Here on Tuesday, the outdoor activities are canceled because of a thunderstorm, so each camper is assigned an indoor activity in the morning and a different indoor activity in the afternoon. In how many ways can the two activities be chosen? Well, in the morning, I have three choices: pottery, computers, and music. So three choices. In the afternoon, I don't have three choices anymore because I've eliminated one from my choice in the morning. So pottery can now be, after I've chosen pottery, I now have a choice of computers or music. If I chose computers in the morning, I have a choice between pottery and music. And if I chose music in the morning, I have a choice between pottery and computers. So my choices could look like this, which gives me a final total of 6 possible combinations of indoor activities. 3 for the morning, and then each of those has 2 possibilities to follow. In this case, what we choose in the afternoon is dependent or is affected by our morning choice. So these events are not independent. Let's look at a third example. All right. On the day of the camp talent show, there's time for only one activity. Each camper is assigned either an outdoor activity or an indoor activity. In how many ways can the activity be assigned? Well, I have the 4 choices from the outdoor activities: swimming, canoeing, volleyball, and archery. And then I have 3 more choices on top of the outdoor, which are pottery, computers, and music, which gives me a total of 7 possible ways that I could choose an activity. Since I can only choose one of the 7 possible activities, we say that we're in a situation where the events are mutually exclusive. I can't choose more than one. If I've chosen one, the rest are no longer a possibility. So the 2 principles that came out as a result of these 3 different situations are whether or not events are independent when things occur in sequence. So the way one event occurs does not affect the way the other could occur in an independent situation, which was something like this. Didn't matter what we chose in the morning when we came around to choosing our afternoon activity. However, if events are not independent, for instance, in this situation, where our choices were limited to indoor activities for both the morning and the afternoon, once we've chosen a morning activity, our afternoon activity choices are different depending on our morning choice. The other situation we looked at is whether or not events were mutually exclusive, where the occurrence of one event excludes the possibility the other will occur. That happened in our third example, where we could only choose one of the 7 possible activities. And once we've chosen the one, the other 6 are no longer an option. So it's one thing or the other, not a combination of the 2. So here's the 2 situations we looked at. We looked at a choice where we had an and situation, where we looked at an activity in the morning and an activity in the afternoon. And we used a multiplication calculation to come up with a total where we took the number of ways the first event could occur and we multiplied by the number of ways the second event could occur. And that vertical line there, B vertical line A, is the notation we'll use when we're talking about whether or not B is affected by A. So n of B slash A is the number of ways B can occur after A has occurred. If A doesn't affect B, then it's just the number of ways B can occur. If A does affect B, as in our second example, then that number will be adjusted. So that depends on whether the two are independent or not. Our second principle is the or situation, the number of ways A or B could occur. In that case, we look at whether A and B are mutually exclusive events. If they are, then we simply add the number of ways A can occur and the number of ways B can occur to get a total number of ways that A or B can occur. That's fine as long as A and B are mutually exclusive events.